Hi everyone, and welcome to another joyful session on the MP3672 stuff. I'm aware of that. We've got a week off, so-called reading week or revision week or holiday, as some of you know it. But what I wanted to do is just really cover some of the material that we didn't essentially cover this week. I'll go over this again, but I just thought for those of you who are so keen, so excited to be able to continue your understanding on Simulink and particular SimMultibody, I thought what I would do is navigate us through the next example, which is a simple robotic structure. One thing that we've done all these different things. We've built spinning processors, we've built things like that, but what we've really not done is controlled angles. We've not set particular positions in space to move to. So what I'd like to do is to go through a simple example, which is this. Oh, not this one. Apologies. Which is this one. For those of you unsure what system I'm using, it is Inventor. I know at the university we do teach SolidWorks, but the beauties with Inventor is just to do with licenses. I find that Inventor a little bit more supportive. Anyway, so what I'd like to do is introduce a 180-degree joint around this one. And in fact, let's just pull this apart, because what I'll do is I'll pull this apart and then just give people the idea of how this thing is meant to be built anyway. So what I'll do is, come on you swine, there we go. So I'm going to ground the base piece for where the arm mounts, which is here. As you can see, this is assumed, well, it is actually ground. This is assumed to be an assembly. Now, do keep in mind in your assignment, I'm going to be asking very much the same thing. You're assuming a certain element of this. Some of the parts I will give you are actually real company parts. Some of them I fabricated myself, and some I pulled from reference of places like GrabCAD, just to give you an example for you guys to operate with. Now what I'm doing here is just applying the constraints. Those of you who've never used Inventor, you will probably start to look at this and go, that was very cool. The joints constraint function on this, for me personally, is something just unmatched in any other system. I think it's fab, but anyway, this isn't about the CAD systems. This is about what we're doing here. So what I'm going to do is just again use my joints and just come on, and I'm going to put a fixture there, and I'm going to put a fixture around there. Now what it'll say is how do I want it to function. I don't want this to be anything, so I'm just going to make that rigid for this case. Let's apply that. So what we got now is we've got 360 degree here, 360 degree here, and we've got a mount point here. Arguably, this looks like some type of rigid structure where it could actually slide backwards and forwards. So let's put a slider in here. So if I go again, this isn't really MATLAB. Well, this is a MATLAB session, and we've ended up talking about CAD. Really, this thing could slide up and down. What I'll do for this case, though, is I'll make that rigid too. Apply this for there, and that is really how our system is going to function for this quick example. So we have one here and one here. What I'd like to do is I would like to simply test this system coming from over here, holding its position, bring it right the way across, and then I'm going to get this to do, I don't know, a cycle in and then a cycle back. Something like that. So, but what I need to do is first decide how this is going to work. So as we're well aware by now, this is my base point. So this is going to be the point where I'm going to start from. So I'm going to minimize here. And I ain't messing around. I'm going straight into SimMultibody. So I'll drop into Simulink, and as ever, we now wait a moment. This is on my home. This is on my home PC, so it is a little quicker than what we get with the university options. So again, blank option. We've done this so much now that I'm not gonna really make slow, massive steps through anything, just because I'm well aware of that you guys should know about the base thing that we do every single time. We set up that base testing element. So this will be our solver, this will be our rigid transform to give ourselves an origin. So this would be the not rigid transform, this will be a world frame, and our mechanism configuration. Once we get all this into play, let's get this built, and then let's take a look when it works. Any minute now. Any minute now. Any minute now. I was on such a roll. Oh, here we go. Creating model. You see, it's not just the university ones. So any of you guys have got this installed at home. I don't know if you're running quicker than I, but this isn't the world's worst PC. So it is a beastie software. It is a really beastie software. So yeah, we just gotta give it a minute. How annoying. Finally, and we're in. So, as ever, normal work frame. For the first couple of joints, I just remind you all about the library of where everything is found. So, bring that up, drop to my SimScape, 3, 2, 1. To multibody, 3, 2, 1. Pull that out a bit. So from multibody, let's have a look. Utilities as well. So drop into utilities for a start. So as we know from here, I need a solver configuration. In here, I need my mechanism configuration. That's multibody under utilities. So it's all such a booting up process. It's so annoying. But anyway, it is what it is. Because when this stuff works, as you guys have all found out, it goes really well. So that's mechanism configuration. And last thing I need is a world frame to give me the all important datum of which way I'm operating to. So let's zoom into that particular area, bring that round, snap to there, and then I will do the same thing here. Bring that down, spin it around, and then zoom it into there too, like that. Snap, snap. Oh, and that now is my world frame. Lots ask me why I always do it in a triangle. It's just because it's just to do with, yeah, it doesn't matter. Anyway, so let's move on. So this is what I'm chasing. These components are all in the notes, by the way. There is no write-up for this, so this is why I'm recording this session, because I appreciate there'll be some of you who want to give this a go anyway. So let's get this built. So first things first, I'm going to go file solid. File solid. Let's bring that in. Let's just call this base. Now the beauties with this is I'm gonna be really sneaky with this. I'm gonna use something else. I'm gonna use something called frames, and this is quite nice because those of you who sit and go through this video, you'll be like, ooh, why have we not done this all along? And yeah, I've not tried to be awkward. I've not tried to be difficult. But it's a lot of fun. It makes life so much easier. I wanted you guys to go through the pain of actually building these things, and then when you actually realize what frames do, you'll be like, oh my god, why have we not done this sooner? And am I sorry? Not really. So there's my base. I'm going to choose a density. And I'm going to go, let's have a look. I'll go custom mass. Let's go something relatively heavy-ish for a single base. So I'll go 4 kilos. Update that for 4 kilos. That gives my density and moments of inertia. And then, right, so this is where you're going to go, what? Well, you might do. You might do, I'm just saying. So, there's my base. I've changed it white just because, you know, well, the original was white. So, what I'm going to do is use this top as my key point of frame. So, I'm not going to change that R. That R, if I slip onto my piece, that R actually starts from the base. But we do have some problems. Oh my God, do we have problems? Z is in the wrong axis. Okay, I'm going to apply on there, and let's bring in a new frame. So, I'm going to go dead steady. Well, I say I'm going to go dead steady. You guys can hit pause or rewind. So, what I'm going to do is click on the top edge. I'm going to call. What am I going to call this next one? Let's just call this arm link or AL1 or AL. Well, let's go AL1. Arm link 1. I want to use the geometry reference. I'm going to click on, and I'm going to use that one. See how I clicked on the edge? I clicked on the edge there. Now look at that. See how that just shows me where my center of axis point will appear when it appears. So I click OK, and you go, oh, right. So let's zoom that in a little bit more. Look at where the reference sits. Everything defaults itself to Z. Pain in the backside. Nightmare. So what I need to do is I need that Z to flip itself up. What I would like to do is to make Z where Y is. So what if I say make primary Z along the reference angles of Y. Ooh. All that messing around that we did in the past sessions all solved one single step. However, if you're on a closed loop, you've got to be aware of where you've changed and when you've changed. So this is cool for robot arms, very quick for robot arms. But for something like a closed loop system, like an engine in a cylinder system, anything like that, it can be a little bit more tricky. Not impossible, but it is a bit more tricky. So I'm going to click Save and then Apply. Now what happens if I flip this little bad boy over? Now what happens is I have the base that's connected to the ground, and then I have AL1, which actually is now telling me is the connector. Boom. So what I'm going to do now is go revolute. Again, I'm not insulting intelligences. Let me just have a quick spin. You look here. This thing revolves. Base to follower. Base being the joint of the robot. Follower being the arm that is connected to it. Let's bring that across. Or in fact, in this case, let's not. I think it's probably going to be better to just build one from scratch. We'll file solid. And let's just go, I don't know, bicep, whatever. Arm. 1 or 2, whatever. Unarmed. Hey! Right. So back onto here, and then we go here, and then we're going to go link 1. F5. Boom. That's my link 1. Okay, so I come onto my joints. You look, now this is annoying. You look and you go, what tool did that? Look at that. You see where the actual Z is. So I mean, really, when this was drawn, it was drawn like that. Anyway, I suppose it's relevant. I didn't draw this. I didn't draw this. It was a company download. This. I thought it might be just good for a bit of an example. Okay, back to the point. So we're going to go back again. Let's put some material on this. Let's give it a little bit of density. I'll make this a bit lighter, so let's go 2 kilos, give that a bit of an update. And then, because if I knew the material, I could set a density, as we all well know. What I'll do is drop that to here, and then come out, and then set that to a white. F5, there's my white. And then I need to set a frame. Frame in this case, again, let's go the arm link. This is base. Oh, arm link. Set by geometry. Apply. Again, I'm following the same thing. I've got to make sure it's in the same process here. So I'll go set that to positive Y. And what these will do is link each other together. It's the same thing as anybody who does constraints. If you do a constraint, you've got to do it so it actually follows suit correctly. So if I click there, what I should get in a moment is an arm, which, don't get me wrong, there's probably going to be collision, but I don't care. Just want to get this in position. Once it's in position, I'm in a great position, because I can then begin to look a little further. Spin it up. This is a great start. So what I need to do, will just keep, because this just thinks that it's ultimately perfect bearing. It's going all the way through. Useless for what I want. Okay. Right. What I now need to do is bring this back up a little bit, and I need to add another frame, because if you notice, my R in this case is useless. My R sits over here, so I'm going to pull the R off completely. Press F5. Now what will happen if I come back, you'll notice, come on, this one, if I click apply, you'll notice, whoops, let me pull it out. You'll notice if I put that back and then I'll look back in, you'll notice that R is now gone. I need to add this frame. I need to add a new frame. So I'm going to come back again, and I'm going to go front arm link. And then I'll go base, select on suggestion on here. Click by selection. Then again, following the same process, keeping that in the positive Y, hit save. You look now, I've now got the front and the base, well, follower base of the actual assembly. This is so easy to put together now. It's, it has to be illegal. It's so easy. So, bring that out. Because you got to remember now, I'm just doing the same thing. Bring that across. And this is arm 2. Oh my God. Oh, what I swear to God. So, what I'm now going to do is just jump this across to my link 2. And then onto my link 2. So if I link 2 on here, that's my next positional point of link 2. Now, my base follower in this case is not there. So what I actually want to do here is just select it to mirror what I've done here. So it's there. And then click save at that. If I go back to it, what it should do is not move, which is perfect. Damn it! So there we go. Click save. And now what I should get is the base of what I was after. So I'm going to do the same thing again over here, but this time what I would like to do is do it just from above. Now you notice we're actually now operating to a hole. Not perfect, not impossible. So I click apply and save. Again, you'll notice here I'm going so quick now that it's as I said, it gets really easy. So I'm going to run that on 3. Oh yeah, you look now. So if I'm just to reflect back on the original design, the only thing I'm missing now is this piece. So let's get that next piece in, and then we can actually look at where we are. So the next piece is a little bit tricky. What I'll perhaps do is I might just put a weldment in. A weldment is assumed that when this puts into place, it is rigid. that this thing is rigid in place. I can change that, but I'll just go with the weldment in this case. So let's go weldment. This weld joint, as I said, will allow me to bring in the final piece. So that's 2, let's go 3. Yeah, what's happening now is it's complaining because it's saying you've got all these frames on here, but it's not sure exactly what the hell it's meant to do. So with the file, I'm going to drop that off for the moment because all I really want is just to look at this thing in motion first. Let's just edit this. Oh yeah. Now let's go to edit. So what I now need to do is just bring this round and then give it a position, which I will state the position from this particular point, and then save. Let's see if this works. Click apply. I think there's a problem with that, but I'm just going to have a look. So let's bring it in and go update. Now, see that? That's clearly upside down. That is because the actual part was probably drawn that way. When it was drawn, it was probably drawn extrusion, 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 which, you know, I mean, fine, whatever. Doesn't make my life any easier, but it doesn't matter. Where I've got it passing down the positive Y, I'll just shift this to a negative Y. What it will do by default is invert the actual selection. So if I come back and then update, now I've actually got what I was after. Now if I just run this, just to check, what I should now get is this thing spinning like bonkers, you know, just going crazy, really. Right. Now what I want to do is I would like to perhaps do a 90-degree fixture. Let's go 90 degrees, and then let's go minus 90 and then 180 for the end. Okay, so under the first one, this is going to go 90 degrees. So I'm going to go actuation. I'm going to have torque automatically calculated, but now I'm going to provide motion, which is ace for stuff like this. It is insanely cool what it can do. So let's come back and then jump into oh, I've just gone blank. I remember, right. So this we now need to bring in because we're going to control with a signal control. So I'm going to go Simulink to power stream converter. I went totally blank then. So bring this to here like that. This now is going to give me my all important control unit. And I'm going to do signal. Now in this case, I'm going to do the signal builder. For those of you who are thinking, well, we didn't do that. We did. This is week 1. Don't forget, all signal builder does is it offers a unit. That's all it does. So I'm going to go degrees. I'm going to signal builder, and let's see if we can get something moving in the right direction. So we're running over 10 seconds. Signal builder is set to 10 seconds. What I was saying is over 5 seconds. Well, let's go over 3 seconds. We're going to get signal. We're going to get the robot arm to move from 0, and I want the arm to move 90 degrees. And again, 90 degrees. And then it's going to hold that 90. So this is absolute in what I'm doing right now. So goes from 0 to 4, 90, and then holds that 90. Now what I need to be sure about is this going even the right way? So let's check it. bring it in. Let's bring it across. Let's just get you into a good position. As I've said before, this software, if it was up to me, I would be a poster boy. I love this software so much. So let's just bring it in. Let's run it. So as it runs, starts to calculate. Oh, look at what you could have won. Let's have a look. Oh! Right, this is quite good. I made this mistake. You guys are going to come across this mistake. And what's nice about this is when you first see this, you kind of go, what the hell does that mean? They are telling you everything there, interestingly. But if you've never come across it, you kind of go, okay, yeah. Okay, let's just jump back into here. Now, I made this. I'd love to say I meant to do this on purpose. I didn't. Forgot. Remember, I'm actually going to offer a motor input. With any particular motor input, we know it's going to be second derivative just because we're going to have position, velocity, acceleration of that output. We're providing motion, not torque. So what I'm going to do is go to filter, drop down my filter, and then go to filter input derivative calculated. Ooh, I hear you say. So first order, don't forget, first order would just be taking into consideration the spring and the damping aspect, or the resistor capacitor behavior. So all we really get here, what I actually really need to give me the all important three elements is that second derivative. So I'm going to go second order filtering. Now we're in business. So if I come back, now if I just come back, what it should now try and do is provide others. So let's just run this and see what happens. Oh, no diagnostics. Now I've had students before sit there and go, okay, what happened? This is what happened. Now I know it looks like a total failure. Let's just recap of exactly what's just happened here. So let me just get to a nice position. This is a nice position. Let's just rerun that again. We've just controlled the lower arm. Lower arm's locked into a 90-degree position and held it after the 4 second. We've now got a level of control. Problem is, I'm going wrong way around. It happens. It really does happen. So if you do get that and it goes the wrong way, don't panic. It's just because you're going around the axis. Funnily enough, I did know that this was going to happen, but I just wanted you guys to see the fact that you look and go, why has that happened? That makes no sense whatsoever. It actually does make a lot of sense because this is absolute to its position. So that's all that this is having a bit of a wobbler about. Again, it's nothing wrong. It is just all it is it just needs telling to go the other way. So all I'm going is minus to actually control the behavior around the datum itself. So if I now run this again, oops, run this again. Oh, sorry, recalculate. Damn. Right, see that? We're locking in. Locked it steady. Holds its position after 4. We can now commit to what we're talking about. Let's do a 90 and then a minus 180. So we should get a 90 across, then a minus 180, right, complete. Then that will be our full cycle. Not the most complicated of cycles, I get that. However, it's a nice learning curve because you can look and go, okay, that makes sense. So what I'll do is just come on to my next frame. And again, that was nearly a schoolboy error. But what I'm doing now is providing that all-important motion. So I'm going to bring that down, bring that down, bring that down, bring that down. I am a stippler for having tidy representations of work that you are doing. So please, please, please keep that in mind. Just because, it won't cut it. I do prefer that you do take that approach. So we know that we're going to hold a position and then we're going to go from we're going to go from our present state. So if I just, in fact, let's just push this back because this will get confusing otherwise. Spin this right the way back. So we're going to come from this position And what we want to do is hold. I've just realised that is not middle. We'll have to move that, but we'll do that in a moment. Oh, that is not middle. I wonder if that's to do with a point that I've chosen between that relationship. I will fix that in a moment though, which has annoyed me. So as they come in, we want to get to there, and then we're going to move 90, and then we're going to go minus 180. So I'm just going to see. So I propose we hold 0 position, and then we're going to go minus 90 and then plus 180. So 0, minus 90, plus 180. I think a 2-step process would do. So let's add a step. We'll try this one out. It might not work. I hope it works. Saying that though, looking at that now. I'm going to have in fact, I'm just going to play it. I'm going to play it nice, and I'm going to delete that one out. Yeah, just get rid of signal 2. Bye-bye signal 2. So we're going to hold it. We're going to go hold it from that 90. Then we're going to 4, and then we're going to shift to 90. We have to move relatively quick looking at this. So let's go, what, 3 seconds? Let's go 90. Do it over, so 3, so 7. And then I'm going to go. So I'm going to shift this down to, let's just go 10. Let's just go 10. I'm way overthinking this. Let's go 10, and then let's go minus 180. This is either going to work really well or just smash its way through the robot arm, which obviously would get me fired. But you know. Let's go minus 180. So go 0. Right, swine. Let me just, I want that to go 90. There we go. Right. So right, let's see if this works. So this should be 0 to 90 4 seconds. Then it will go. Well, I've gone 2. It will go 0 to 90 2 seconds, and then return 0 to 180 in the 4 seconds. Okay, so I'll close that off for the moment. Just bring this up a little bit. It's just because now we're starting to get a little bit messy. And again, it's all about being tidy and well represented, so you can actually see what's going on. So you look now, I can clearly see what's happening. I have no shame. I am a total video gamer, so yeah, don't judge me. Right, so if I recalculate and then go again. Hold it through to 90. Stop, return, all the way back 180. Now, let's just run that again. Through to 90, return back to 0, 90, then all the way around to 180. So, that's... Oh, should I answer that? Oh, I should answer that. That's just a bit of a prickish thing to do otherwise. So I said it's absolute. And I'd love to say I meant to do that. I totally forgot myself. I've gone minus 180. So that's 90 to that 0, then 180. So it's bound to go through the arm. So if I go minus 90, what it should do is do that all important full sweep that I was after. So let's recalculate, run again. So it runs in, holds its state, holds back, just 0, comes all the way around and should hold at that 90. So there's my cycle. So these are just visualizers, by the way. You know, it just allows you to see what's going on. So I've now got my visualization. I've now got a piece running. So let's now start to extract a little bit of data. Let's see what the overall of that arm is. What the hell does it actually hit, you know? So where does it actually, where does it actually go with that? So let's do a body first. So I'm going to go transform. Whoops. Transform. I want to go transform sensor. So I'm bringing the transform sensor. A great bit of kit, this one. And I'm going to come this back here like that. And then I'm simply going to bring in a world frame. This allows me to offer a reference, a starting point, if you will. So what I'll do here is from my transform, I'm just going to look at translations of, let's have a look. Now, I would like to see what the translational aspect of X and Z is, just to look at what that actually does. So I'll go X and Z, then bring this in. I'm going to go an XY plot. So I've got an XY graph. I really do like these. If you need to know an overall space, if you need to know what's going on, what's happening, these are so good. So I'll go power stream simulink converter. So this now brings in the power stream. Whoops. Whoops. Come on, yes. There we go. Now it's that way and that way to there. Then bring that down. Let's go there and then to there. So that's just snapped all these bad boys together. So I run it back in again. So let's bring it back. So you can see there. You can actually see there it's not straight. You see that? That just tells me that that has been mounted incorrectly, because you see there it's not a circle, it's actually an ellipse, which is really interesting. We'll fix that in just a moment anyway. In fact, no, let's fix that right now. So let's just take a look back. Where did I go wrong? And I'm betting you my love no money it's coming from... Well, I mean, no. Let's have a look at the base on that. So if I check that as a marker, yeah, you see, if you look there, it does look out. So let's just try that as an edge. See if that fixes it. It didn't look right to me now. It didn't look right. So let's just pan that back, recalculate, and let's just pan it back up. And you look now, it's looking a lot better. So let's just rerun that through again. And snap you across. Well, I suppose it gives me a lot more there. Okay, so we've now got a control of here. What I'd like to also do is actually consider what's happening around the composite elements for the forces. So let's just consider the total force that's coming out of here. Lots to be seen from this. So let's bring that across. You know about units by now, so I'm not going to insult anyone's intelligence with that. I'm going to go to sensing in this case, and I would like to know, I'm going to bring out the actuator torque, because don't forget, I added in actuator torque, so it's automatically calculated now. And I'll do the same here as well, and I'll go actuator torque. So now what I'm getting is a real performance snapshot of how well this thing's actually doing its job. And if it's any good, because it's all right doing it, but it might be absolute rubbish, really, you know. So bring this in. and then to there. So we'll snap you to here, snap you to here. Right, so let's go scope. And then I think really that is the example of this arm. So I'll bring this in and then let's just have a look. So I'm going to go 3 outputs, I'm going to go 3 over the top and go like that. What I'd like to know is, oh, there is one big thing actually. Run it in. Right, look at that. Okay, so what I'm actually interested in is the bottom one. So let's have a look at the bottom one. If we just look at this, I know it doesn't look much. However, what if we just scope these key areas? So let's just scope this area first. And then let's just look at, first let's look at the peaks and the troughs of all this. So let's bring that again. You look there, right. 0 to 30 Newton meters? Because I don't think I changed the units. I don't think I set the units yet. Yeah, you look there. 600 Newton meters to get this thing moving. This thing weighs a ton. Just check my units. Did I put units in there? So this is the torque that's coming out of it. And what this is actually suggesting is how much it's struggling to move, if you will. So when you get to a key point in any robotic system, it needs to actually be able to spike, to be able to challenge which way it's moving. I really need to set my units to be clear on this, but these are the peaks I'll be looking for. This then allows me to start looking at, say if this is a 7 Newton meter, or something like, I need to check this, but let's say if this is 7 Newton meter output, then what I need to do is I would be looking for something which was so let's have a look. We're looking for something like 8 Newton meters, for example. So a good choice for something like this may be, let's have a look what we can buy. Well, that's a good one. 8 Newton meter. Ah, right. So we have this stepper motor here. This stepper motor, the NEMA 34, given its output for 8 Newton meter, I've had to go above. Now you go above because if you just scope a motor to operate 100%, it is the same as setting your motor to, like, going out in your car, for example, and running it to 100%. It's the same as doing that. And if that's the case, then you are just glutton for punishment. That's what this really is. So when you're selecting these motors, you always, the thumb in the wind type of assumption is 70%. Whatever you're calculating to be your maximum is going to be 70% of the overall of what this thing can generate. You don't run it to 100%, or else you're just getting yourself into trouble. Okay, so that in itself, we've been able to establish a motor which will be able to do what we need it to. I've got an overall coverage of where the arm actually sits. By default, I could control this to tell it to move in a different area, to tell me which way to go, things like that. In this case as well, we also used frames. If I just pan back to the original arm, if this was to be, I don't know if somebody actually told me what this was last year. I have no idea what the hell this thing is. But if this was to be something that was going to oscillate in some cases, we could easily do that. But what you should now start to see is that what we've been able to do is remove all the complications of the CAD and all that to it, and now we're in a position of doing whatever we want to this, and it will tell us how well it will do it. And again, all I did in this case would do a 90 to a plus or minus 90 positional state. I did actually forget what I was doing, and that's where I went a little bit over. Great thing is here, Signal Builder. Signal Builder will just do it all for you. It is so good. But do keep in mind, without setting key units, things like that, this thing will not know exactly what the hell it's doing. So if I set that to revs, this thing, the robot will just spin like crazy. Okay, so if you're curious as to where you can find it, I feel like an advert. If you're curious as to where you can find this model is on Blackboard now, and you can see this. The other thing is as well is this year's assignment has now been uploaded. Do take a look, read it and weep. If there is any burning questions, jokes aside, guys, please do reach out. Let me know. Let me know if there's anything. I wear the dyslexia badge very proud. So if you do spot a spelling mistake, it is what comes with the territory. Do let me know. I'm gladly I will change any typos that I come across. Other than that, I hope you found this a bit of a benefit, and I am around all week. And if you do need anything, again, reach out, drop me a line, drop me an email. Either way, I will get back to you as soon as I can. Right. Other than that, I was going to say, don't forget to like and subscribe. Yeah. But yeah, if there is anything, do let me know, and I will speak to you all soon. Cheers, guys.